Hey everyone, it's that time of month again. We're going to go over electrical safety. On average, one worker is electrocuted on the job every day. There are four main types of injuries. Electrocution, which is death due to electrical shock, burns, and falls. Some terminology: current, movement of electrical charge; resistance, opposition to current flow; voltage, measure of electrical force; conductors, substances that have little resistance to electricity; insulators, substances that have high resistance to electricity; and grounding, conductive connection to the earth which acts as a protective measure. Electrical shock is received when current passes through the body. Severity of the shock depends on the path of the current through the body, the amount of current flowing through the body, and the length of time the body is in the circuit. Just because you have something that says low voltage, it does not mean it's low hazard. Dangers of electrical shock: currents greater than 75 milliamps can cause ventricular fibrillation, rapid, ineffective heartbeat. This will cause death in a few minutes unless a defibrillator is used. 75 milliamps is not much current. A small power drill uses 30 times as much. Now remember, a milliamp is just 1/1000th of an ampere. How is electrical shock received? When two wires have different potential differences or voltages, current will flow if they are connected together. Most household wiring, black wires are at 110 relative to ground. White wires are 0 volts because they are connected to ground. If you come in contact with an energized black wire and you are also in contact with the white grounded wire, current will pass through your body and you will receive a shock. If you are in contact with an energized wire or electrical component and any grounded object, you will receive a shock. You can even receive a shock when you are not in contact with the ground. If you're in contact with both wires of a 240 volt cable, you will receive a shock and possibly be electrocuted. Electrical burns: most common shock-related non-fatal injury. These occur when you touch electrical wiring or equipment that is improperly used or maintained. Typically occurs on your hands. It's a very serious injury that needs immediate attention. So in other words, if you have any electrical burns, call 911. You don't know what's going on inside of your body that could cause damage to you. Electrical shock can also cause indirect or secondary injuries. Workers in elevated locations who experience a shock can fall, resulting in serious injury or death. If you look at that picture, there's a lot wrong with it. You guys have called it out before in prior safety meetings. No safety glasses, no gloves. Don't know if that box is live or not. Ladder's not locked out. There's a lot can go wrong with that. Inadequate wiring hazards. A hazard exists when a conductor is too small to safely carry the current. For example, using a corded tool with an extension cord that has too small wire for the tool. Tool current greater than cord capacity. This causes overheating and possible fire without tripping the breaker. The breaker is the right size for the current, but not for the smaller cord. Overload hazards. If too many devices are plugged into a circuit, the current will heat the wires to a very high temperature, which may cause a fire. If the wire insulation melts, arcing may occur and cause a fire in the area where the overload exists, even inside of a wall. Grounding hazards. Some of the most frequent violated OSHA standards. Metal parts of an electrical wiring system that we touch, switch plates, light fixtures, conduit, should be 0 volts relative to ground. Housing of motors, appliances, or tools that are plugged into improperly grounded circuits may become energized. If you come into contact with an improperly grounded electrical device, you will be shocked. Overhead power line hazards. Most people don't realize that overhead power lines are usually not insulated. Power line workers need special training and PPE to work safely. Do not use metal ladders. Instead, use fiberglass ladders. Be aware of power lines when you work with ladders and lifts. Electrical protective devices. These devices shut off electricity flow in the event of an overload or ground fault in the circuit. Include fuses, circuit breakers, and ground fault circuit interrupters, GFCIs. Fuses and circuit breakers are overcurrent devices. When there's too much current, fuse will melt or the circuit breaker will trip open. Ground fault circuit interrupter. This device protects you from dangerous shock. The GFCI detects a difference in current between the black and white circuit wires. This could happen when electrical equipment is not working correctly, causing ground fault. If a ground fault is detected, the GFCI can shut off electricity flow in as little as 1/40th of a second, protecting you from a dangerous shock. OSHA electrical requirements. Next few slides are going to be some examples of OSHA electrical requirements. Grounding path. The path to ground from circuits, equipment, and enclosures must be permanent and continuous. Violation shown here is an extension cord with a missing ground prong. That's why it's important when you do your your AGCP to make sure there is a grounding plug on all the extension cords and that they ohm out properly. Handheld electric tools. Handheld electric tools pose a potential danger because they make continuous good contact with the hand. To protect you from shock, burns, and electrocutions, tools must have a three-wire cord with ground and be plugged into a grounded receptacle, or be double insulated, or be powered by a low voltage isolation transformer. Guarding of live parts. You must guard live parts of electrical equipment operating at 50 volts or more against accidental contact by approved cabinets, enclosures, or location or permanent partitions, or elevation of 8 feet or more above the floor working surface. Mark entrance to guarded locations with conspicuous warning signs. Must enclose or guard electrical equipment in locations where it would be exposed to physical damage. Violation shown here is physical damage to the conduit. Cabinets, boxes, and fittings. Junction boxes, pull boxes, and fittings must have approved covers. Unused openings in cabinets, boxes, and fittings must be closed. No missing knockouts. Photo shows violations of these two requirements. Of course, it doesn't have a cover, and there's knockouts missing. Use of flexible cords. More vulnerable than fixed wire. Do not use if one of the recognized wiring methods can be used instead. Flexible cords can be damaged by age, door window edges, fasteners, abrasion from adjacent materials, and area activities. Improper use of flexible cords can cause shocks, burns, or fire. Permissible uses of flexible cords: pendant or fixture wiring, portable lamps, tools or appliances, stationary equipment to facilitate interchange. Prohibited uses of flexible cords: can't substitute them for fixed wiring, cannot run them through walls, ceilings, floors, doors, or windows, can't conceal behind or attach to building surfaces. Clues that electrical hazards exist: trip circuit breakers or blown fuses, warm tools, wires, cords, connections, or junction boxes, GFCI that shuts off a circuit, worn or frayed insulation around wire connection. If you see any of these, feel any of these, make sure you figure out what's going on before you continue work. You need to fix that hazard. Training. Employees need to be trained with electrical equipment and safe work practices, including de-energized electric equipment before inspecting or making repairs, using electric tools that are in good repair, using good judgment when working near energized lines, use appropriate protective equipment. Summary: you have your hazards: inadequate wiring, exposed electrical parts, wires with bad insulation, ungrounded electrical systems and tools, overloaded circuits, damaged power tools and equipment, using the wrong PPE and tools, overhead power lines. All hazards are made worse in wet conditions. Protective measures: proper grounding, use GFCIs, using fuses or circuit breakers, guarding live parts, proper use of flexible cords, and training. That's all for this month. If you have any questions, comments, concerns, you know how to get a hold of me. My phone number's in the email. You have my email address. You can always call the office and get a hold of me. If you need anything, let me know. It's the end of the month. Do your fire extinguisher check. Get it inspected, signed off on your green tag. And have a happy Halloween. We'll see y'all out there.